Hi everyone, in today's lesson we're going to be able to prove continuity and differentiability algebraically. We've already spoke about continuity and differentiability graphically, so now I'd like to talk about how we can prove them algebraically. So the definition of a continuous function is if the limit from the left of a function equals the limit from the right of the function, which also equals the value of that function at that specific x value, then the function is continuous. A function is differentiable if the limit from the left of the derivative is equal to the limit from the right of the derivative, which is equal to the derivative of that value. So let's put these two definitions into play with an example. So example number 1 says, determine algebraically if the function is differentiable, continuous, both, or neither at the x value where the rule for the function changes. So they mean this, like x is less than 3 and then x is greater than or equal to 3. This is where the rule changes. So the first thing we need to determine is where's the left side of the graph and where's the right side of the graph. So if you look at a number line and if you put 0 here just for perspective and say you put 3 here, all numbers that are less than 3 are on the left side of the graph, and all numbers that are greater than 3 are on the right side of the graph. So we're going to label this one as my left. Maybe I'll use the right color. So we'll label this one as my left, and we'll label this one as my right. So now we know which one is which. Now we can go ahead and prove continuity or differentiability. So in order to do continuity, we'll start there. We need to plug in the limit from the left at x equals c. So the c value here is 3. So we want to determine if the limit as x approaches 3 from the left of f of x is equal to the limit as x approaches 3 from the right of f of x. And we want to see if that's equal to f of 3. So in order to find a limit from the left, all we're going to do is plug 3 into this original function here. So let's go ahead and do that. So 3 squared minus 16 times 3 plus 8. And then if we want to find the right side of the graph, the limit as x approaches 3 from the right, we're simply going to plug 3 into this bottom function. So negative 10 times 3 minus 1. Now, if we wanted to find f of 3, we would just look where the closed circle would be or the line. So really, f of 3 would be the same as finding the limit as x approaches 3 from the right. So in order to solve an equation that has two equal signs, you really only need two pieces that you can work with, and you really don't need the third one. All right, take a minute, pause the video, type this into the calculator and this into the calculator, and get an answer, and hit resume when you're ready. Okay, so I got negative 31 on the left side, and I also got negative 31 on the right side. So since the limit from the left is equal to the limit from the right, which inherently will be equal to f of 3, that means the function is continuous. So we can go ahead and label continuous for the left side. So now to prove differentiability. So we need to prove that the limit as x approaches 3 from the left of f prime of x must equal the limit as x approaches 3 from the right of f prime of x must equal f prime of 3. So in order to actually plug in a limit, we need to first calculate the derivative, or f prime. Notice this function, we needed f of x. This function, we need f prime, but from the left function. So here is my left function. So we're going to need to use the power rule, and we need to take the derivative. So if we do that, we're going to take the 2, bring it in front, so it'll be 2x, and the derivative of negative 16x is negative 16, and the derivative of a constant is nothing. So that's your derivative, and we need to take the limit as x approaches 3. Now, from the right side, we're going to do the same thing. We need to take the limit as x approaches 3 from the right of f prime, which is the right side. So this is my right side. So the derivative of negative 10x is just negative 10, and the derivative of a constant is 0. So negative 10 goes there, equals f prime of 3 just means taking the derivative and plugging in 3 where it's equal to, which would be there. So we don't really need that. Like I said, we just need two pieces. So let's work with the two that we have. So now that we have our derivatives, all we're going to do is plug in 3. So 2 times 3 minus 16. And on the right side, this one's actually unique. I want to take the limit as x approaches 3 of negative 10. Well, since I can't plug into it because there's no x value, that means the limit is always going to be negative 10. So there's nothing you need to do there. So if we take a minute and do the math, this left side is negative 10 and this right side is negative 10. So because the left side equals the right side, we can say this function is differentiable. So in order for a function not to be continuous or not to be differentiable, the left and the right sides would not have to be equal. All right, let's try one more example. So example number 2, same concept. The question is asking to find the limit as x approaches c. In this case, your c is 8. So less than or equal to 8 is my left side of the graph, and greater than 8 is my right side of the graph. So let's rewrite what we need. We need the limit as x approaches 8 from the left of f of x, and we need the limit as x approaches 8 from the right of f of x, and it needs to equal f of c, or in this case, f of 8. So the limit as x approaches 8 from the left of f of x. Well, you could write down f of x if you want. So you can make this x squared minus 10x minus 19. And we need to take the limit as x approaches 8 from the left. So we're going to plug in 8. So 8 squared minus 10 times 8 plus 9. And now we're going to play with the right side of the graph. So we need the limit as x approaches 8 from the right of my f of x function, which is negative 2x minus 19. That's my right side. And I'm going to plug in 8. So take a minute, pause the video, type these into the calculator, and hit resume when you're ready for an answer. All right, so on the left side of the graph, I got negative 35. And on the right side of the graph, I got negative 35. So since the left side equals the right side, we can say the function is continuous. All right, let's try differentiability. So I want to take the limit as x approaches 8 from the left of the derivative of the left side. So the derivative function, take the 2, bring it in front, 2x. The derivative of negative 10x is negative 10. And the derivative of a constant is nothing. And I want to see if this is equal to the limit as x approaches 8 from the right of the derivative of the right side. So the derivative of negative 2x is negative 2. The derivative of negative 19 is nothing. And again, we really don't need this side here. You can write it if you want. This will be f prime of 8. So let's do some calculations. The limit from the left means we're going to plug in 8. So 2 times 8 minus 10. And the limit from the right means that we're going to plug in 8. But again, there's nothing to plug in, so we're just going to say the limit is negative 2. So if we calculate the right side, 16 minus 10 is 6. So you're going to notice that 6 is not equal to negative 2. So the function is continuous, but it's not differentiable. All right, let's just do the last one. It shouldn't take too long. So again, same thing, determine if it's continuous, differentiable, both, or neither. So the less than values are going to be your left side of the graph, and your greater than values are going to be your right side of the graph. So the first one, to prove continuity, we want to prove that the limit as x approaches negative 1 from the left of f of x, which is x squared plus 24x plus 3. We want to see that that's equal to the limit as x approaches 1 from the right of the right function, 16x minus 13. Again, you don't need this. I'm not going to write it because I'm kind of running out of space here. So if I want to find the limit as x approaches -1, I'm just going to plug in -1 here. I'm going to plug in -1 here. I noticed this should be a -1. So let's go ahead and do that. So -1 squared plus 24 times -1 plus 3. And the right side of the graph, we're going to plug in -1 as well. So take a minute, pause the video, and let's see what we get. Okay, so the left side of the graph, I got -20, but the right side of the graph, I got -29. So what this means is that the function is not continuous. And honestly, that helps us tremendously for differentiability. So the definition of a differentiability function is that it must be continuous first. So you can say, because the function is not continuous, the function cannot be differentiable. Okay, so in order for a function to be differentiable, it first has to be continuous, and then it has to follow this definition. Okay, so that's it for today. If you have any questions, please jot them down and then ask me in class tomorrow. Have a great night.